So we can apply what we looked at in the XY coordinate plane to triangles. And we can do that by starting with a triangle situated in the coordinate plane with one of the angles here, angle A, at the origin. So let's go through the trigonometric functions for angle A. So the sine of angle A, sine is y over r, so for us that's going to be A over c. What's cosine? Well, the cosine of A is x over r, so b over c, and the tangent of A is A over b because it's y over x, so A over b. So that works really well using x, y, and r to orient ourselves as long as we're looking at the angle that's at the origin. But what happens if we're looking at angle B in this ABC right angle triangle? Well, now we have to think about it a little bit differently. So rather than thinking about x, y's, and r's, we're going to think about the relationship between the sides and the angles. So side A is opposite from angle A, side B was adjacent to angle A, and side C is the hypotenuse. So we can think of A over C as being opposite over hypotenuse. B over C, therefore, is adjacent over hypotenuse. And tangent A over B is opposite over adjacent. We often remember this with the mnemonic SOHCAHTOA, which tells us that the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So when we're talking about triangles, SOHCAHTOA is going to be our go-to. Of course, when we're talking about the coordinate plane, we'll have to go back to talking about x, y, and r, which is why we started with that nomenclature. So the reason this becomes important is we do also want to look at angle B. So what is the sine of angle B? Here just given by a capital letter. Well, sine is opposite over hypotenuse. But now we have to be careful to label our sides appropriately for angle B. So for angle B, side B is the opposite side, and side A is the adjacent. The hypotenuse is the hypotenuse is the hypotenuse, so we don't need to change that. In fact, that's always the first side that I label in a triangle. So the sine of angle B then is opposite over hypotenuse, or B over C. The cosine of angle B, adjacent over hypotenuse, in this case is A over C. And the tangent for angle B is B over A. So let's jump in and solve our first problem. We're given triangle ABC. So I'm going to start by drawing a picture. It's just a sketch, doesn't have to be perfect. Mine is fairly rough. And we're told that it has angles ABC. We know that from triangle ABC, which is the 90-degree angle. We're told that C is the 90-degree angle, so I'll label that first. I can choose either of the other two as the 50-degree angle, so I'll label the one up here, and then the third angle is B. So now we can label the sides. The side opposite angle C is side C, the side opposite angle B is side B, and the side opposite angle A is side A. Let's write in the remaining values. We know that angle A is 50 degrees, and we know that B has a value of 6.7 units, whatever units this is in. Okay, so what are our unknowns? Well, we need to find side C, side A, and angle B. As long as we get those three pieces of information at the end, it doesn't matter how you find them. You may not choose exactly the same order that I'm going to approach, but I'll show you one way to do it. All right, so to me, the easiest one here to find is actually angle B. And that's because I know two sides of the two angles on this triangle, and I know that the interior angles of the triangle will sum to 180 degrees. So the total is 180 degrees. If I subtract the 90-degree and the 50-degree angle, I'm left with 40 degrees, so angle B must have a value of 40 degrees. You may have noticed I can just take 90 degrees and subtract 50 because the two angles that are not the right angle must add up to 90 degrees. All right, so now I'm not sure if I want to tackle A or C first. So one strategy here is to write out the trig functions. And I'll do that with the angle that we know. So I'll do that with angle A. So the sine of angle A, which has a value of 50 degrees, sine is opposite over hypotenuse, is A over C. The cosine of angle A, or 50 degrees, cosine is x over the hypotenuse. It's the adjacent over the hypotenuse, so it's 6.7 over C. And the tangent of 50 degrees is A over B, so A over 6.7. Now you can see that two of these are going to be useful for solving for an unknown. Unfortunately, the sine has two unknowns. It has two unknown sides, so instead I'm going to use cosine and tangent. So let's start with cosine of 50 degrees is equal to 6.7 over C. Our unknown is C. It's hiding there in the denominator, so our first job is to remove it from the denominator. If I want to eliminate it from the denominator on the right-hand side, I multiply both sides by C. That gives me C times the cosine of 50 degrees is equal to 6.7. Now C is multiplied by the cosine of 50 degrees, and of course cosine 50 is just a value. You can enter cosine of 50 degrees into your calculator and find that value immediately, or you can just leave it as its exact answer for the moment. In any case, to eliminate it from the left-hand side and isolate C, we're going to undo multiplication by dividing both sides by the cosine of 50 degrees. That eliminates cosine of 50 degrees and allows us to solve for C. So C is 6.7 divided by the cosine of 50 degrees. You're just going to punch that into your calculator and we come up with 10.4. So side C has a length of 10.4. So we know that the tangent of 50 degrees was A over 6.7. So we have one unknown out of the three, so we can use the tangent of 50 degrees to solve for A. A is already in the numerator. Its only problem is it's being divided by 6.7. So to isolate A, we only need one step, and we're going to multiply both sides by 6.7. So that cancels from the right-hand side, and we find that A is equal to 6.7 times the tangent of 50 degrees. So A is equal to 7.98. Let's tackle another one. In this instance, all of our information is given in the diagram. So we know side C, we know side B. Side A is an unknown, as are the two angles that are not the 90-degree angle, angle A and angle B. So we need a slightly different approach here because we certainly can't find the angles immediately. Maybe something jumps out at you. I'm noticing that I do have two of the side lengths. For example, if I'm thinking about it in terms of angle A, from the perspective of angle A, side B is the adjacent side, and side C is the hypotenuse. So adjacent over hypotenuse, that would be our cosine. So the cosine of angle A is 56.82 over 79.55. So with two known sides, we can plug those into a ratio and isolate the angle from the appropriate trig function. How do I isolate angle A here? Well, I'm going to take the inverse cosine of both sides. So we find that A is equal to inverse cos of 56.82 divided by 79.55. Dropping that into a calculator gives you 44.4 degrees. So we know angle A. So now I know two of the interior angles of the triangle, so I can find angle B by subtracting 44.4 from 90 degrees, knowing that the three have to add up to 180, and I already have a 90-degree angle. So that gives us an angle of 45.6 degrees. So fairly straightforward to find that other piece, as it turns out. And then finally, we need to find side A. Side A you can absolutely use trigonometry for. But just to show a different technique, why don't we try Pythagorean theorem? If we know two sides of a right angle triangle, we can use the third one. So Pythagorean theorem would say that c squared is equal to a squared plus b squared, and it really is c squared here because angle C is our 90-degree angle. But it's a that we're solving for, so we're going to subtract b squared from both sides, which gives me a squared is equal to c squared minus b squared. And because I'm not interested in a squared but merely a, I'm going to take the square root of both sides. Maybe you've actually started with this statement, and that's okay as well. So now I simply need to fill in the values for c and b, being careful to remember that we do have a subtraction. Now this is a minus sign in between the two. So side A is the square root of 79.55 squared minus 56.82 squared. Dropping all of that into your calculator should yield 55.67. So there's all three missing pieces: angle A, angle B, and side A.